My name is Brian Putt. Today I'd like to talk to you about one element of decision quality or decision analysis, and that is cost and schedule risk analysis. What you're going to view here was an extract from a presentation I gave to the International Council of Systems Engineers. So now I'd like to turn to cost and schedule risk analysis. It's really important in project selection. And the Gorgon project probably highlights this challenge because when we first estimated the cost of this project, it was going to be $37 billion. It's now grown to $54 billion. Okay? At the same time, Brent crude prices have more than halved since we decided to go ahead. So you can imagine that the economics have declined considerably, costs going up and revenue, at least today, going down. Not to say that, 3 or 4 years from now, we'll be back up to what was projected when we sanctioned the project. Okay, it was sanctioned in 2009, and now in 2016, it's getting going. So why is it important to understand cost and schedule risk? Well, a lot of the federal programs have had large cost overruns, and this is no different for many of the private companies as well. The Healthcare.gov site, launched in 2013, a lot of news around that, grew from 464 to 824. Okay, there was a Veterans Affairs hospital that more than doubled in cost from 254 to 616. And there's the International Space Station that quadrupled from 17 to 74 billion. We can also talk about the San Francisco Bay Bridge that went up substantially and being modified. The original estimate, would you believe, was to upgrade both parts of that bridge for $250 million back in 1995. But at the end of the day, they spent $6.5 billion just rebuilding the eastern span. Didn't even do the whole thing. And they started that project in 2002 and completed it in 2013. So it's 11 years being built for the $6.5 billion. So how do you get a better handle on cost and schedule risk analysis? Well, first of all, you can conduct a workshop. And it represents a comprehensive review of the project that quantifies the potential uncertainties and the risk factors. And it's going to utilize an Excel tool to capture these uncertainties and the rationale. And it's going to generate some curves and tornado charts. And I've used SIPmath, but other people do use Crystal Ball or other simulation software. It's also useful in mitigating the schedule. So we can show that in the Excel model I'm going to show you here. But it's important to perform both of these cost and schedule analyses in a single integrated cost and schedule workshop. So we need to understand how, if the schedule slips, there's kind of a burn rate, right, that you're going to need to add into the cost uncertainty. These are kind of the general outputs that you're going to see, the elapsed time. And for those that may not be familiar, this is a cumulative distribution curve. And basically, any point along here, it says, okay, there's a 50% chance, roughly, that it's going to be, let's call that, looks like 1070 days. It's 50% chance it could be less than that, and a 50% chance it could be more. It could never be less than, we'll call that 930, and it's generally not going to be more than 1220. So we're somewhere in this band, and this shows the shape of the curve, similar for the cost uncertainty. So when do you conduct these things? Well, really it should be done early on. A concept selection at the front end engineering design, and then you might do it something in the FID, but by that time you're doing detailed engineering, probably less important. Really important here at the concept selection because as we'll see, there can be lots of roadblocks to even doing these things because people have started to lock in early, particularly from a planning perspective. So you want to do them early in the project. So you're probably familiar with PERT diagrams. It shows relationships between these components. I just want to give you a flavor for this is how it's done. So I want to take a look at a SIPmath model, and so you can better understand what I'm talking about. But before we begin, are there any questions? No questions? Are we ready to run away? Okay, let's do it. So here's the model. And you've already kind of seen these graphs. And so I'm showing you here the elapsed time, and this is showing it same thing but showing by dates rather than days. And here's the cost. And we can break the cost down into that which is, the engineering and people, and then there's also the slippage. This would be the burn costs as my schedule slips. And these need to be added together probabilistically. So what kind of inputs do we need here? Well, we need to break out the project into different activities, and so here we broke it out into front-end engineering. We had a pipeline to build, we have a platform, we have topsides. This is an oil-related problem because that's my history, right? And then we use a triangular distribution to identify the range of outcomes, and we don't have time to go into why the triangular, but that's what we're going to use here. And then it basically says what is the relationship between these. So for example, this platform, the platform says I can't start the platform any sooner than the maximum of when the detailed engineering's done and I've got the construction permits, and that has to be added on to when does this is the leader of the lag of that. So these activities have relationships to each other as indicative of the influence diagram I showed you earlier. Now with those uncertainties, that's how we're going to generate these charts. And so what happens is, if I looked at the base cost or the base schedule, the results are really way down here at the P10 or less in the case of the cost. So if I just look at if I took the minimum, took the most likely outcome here and just looked at that schedule, that's what I would get. And so you come back to your decision board and you say, well, gee guys, we've done the CSRA, and now, we originally told you it was going to take 1,000 days, and now it looks like it's going to take, let's see, we're on the blue line. It's going to take an extra 2 months. And the decision board's not real happy about that, but that's the way it is. And they say, well, what can you do to improve it? Well, so we look for ways to mitigate. So we've included some mitigations here, and they talked about getting an early acceptance for the construction permits. And here's another one where they're going to use 3D printing for part of the platform. That's not only going to reduce the schedule, but I think it also is going to reduce the cost. Yeah, it has the potential for reducing the cost, but I'm going to be successful in this 3D printing only 25% of the time. So we can put in a probability for the mitigation. So now let's turn on those mitigations. Okay. And it automatically recalculates. And now you can see that my elapsed time has gone from this reference case here. I've reduced the time substantially on the down. So this is good. This is good. All right. At the same time, I have reduced the cost a little bit. So these are really good mitigations, and they reflect this probability of actually being able to do the mitigations only 25% in the case of the 3D printing. And this is all done, not to get into too much detail, using something called a data table. And that's why this all can be done without any macros. There's no macros in here other than to do some sensitivities. I don't think we have time to get into that, but you can go look and see what is the impact of the minimum and maximum of each of these activities and find out how often they're on the critical path. All right, let's get back to our presentation here. What are some of the roadblocks to a good cost and schedule risk analysis? Well, my budget's already been set. The cost estimate's already known. How can I change it now? You guys are telling me it's going to cost 20% more. How can I go back and tell my planning department that it's going to cost 20% more? They'll kick me out of the office. So we have to stick with the old budget. Now, the project schedule, we've already committed that to the external community. So how can we change the schedule now? Let's make sure. Can't we improve that schedule somehow? The other problem is that when people start talking, they're thinking about their own little segment. They want to be responsible for that. They want to demonstrate that they're really efficient and they can do it well. And so they're not thinking about everything else that's happening. Remember, we talked about having interdisciplines. This is going to really require bringing together drillers, facilities engineers, maybe some of the tax people, the planning people, environmental reviews. So there's lots of people who need to be involved in setting up these schedules. And then there's the issue of getting unbiased estimates. And that's a whole nother subject. There's having a whole nother presentations on how to try to get more unbiased estimates for cost and schedule. And then there's just the issue, well, hey, we've got to get going. We don't have time for all this such activities. This doesn't really have to take a lot of time. Typically, this can be done in the whole workshop is typically 2 days, but there's a prep before and then probably some review afterwards. So it's a couple of weeks for sure. So this brings us to our decision quality diagram here with the 6 spokes. Where does cost and schedule risk analysis fit in? Well, it fits into the meaningful and reliable information. For without that, we cannot make a quality decision. Thank you for watching the video. If you want more information, visit probabilitymanagement.org, or you can view my YouTube presentations. Thanks again.